welcome back. What I want to talk about today is just elaborating on the graphing that you learned about yesterday. And what we're going to start out with is just kind of a quick review on what happens when you graph and what a solution is. So the solution to a system of equations when you graph them is really the ordered pair where the two lines intersect. Or it doesn't even have to be lines. I mean, we're working with lines, but we'll say where the functions intersect. So they might be quadratics, they might be linear. We're going to focus on linear. Okay? What happens if the functions intersect once? Well, then we say that there is one solution. And if you look at the equations themselves, that means that they have different y-intercepts. And they also have different slopes. All right, so actually they could have the y-intercepts. We'll say different y-intercept sometimes. And if, like, for instance, you might have this and that. I mean, it has the same y-intercept, different slopes. But that's, I guess, kind of a special situation where their intersection point actually falls on the y-intercept. So, generally you're going to have, two lines. And this right here would be considered your solution. Again, there's only one solution when we're working with straight lines, when they intersect in one spot. Sometimes they never intersect, and so we'll say that these are no solution problems. And what does that mean in terms of the lines? Well, number one, it means that they have different y-intercepts. In other words, they're starting at different points, let's say here and here, but if they're never going to cross, they have to have the same slope. In other words, if this line takes off in this direction, all right, the other line has to take off kind of in the same direction so that they never intersect. Those are going to be basically parallel lines. Again, this is a review from yesterday, so this should look pretty familiar. The last situation, what happens if they end up in exactly the same location? Well, then they have the same y-intercept. They have the same slope. And we call this we call this set of solutions infinitely many solutions, for the same reasons I showed you in the video yesterday. So you got one line and you got another line graphed basically right on top of the other one. So, you're looking at something like that. And the points of intersection are all over the place. So, like, all over here, these lines are intersecting. All right. Okay, so what we're going to do today is apply this to more of a general setting. What we're going to do is focus on the graphing today, and then starting the next time we work on this, we'll transition more into using substitution and elimination, and that's really where the new stuff starts to come in. Okay, so I'm going to try to highlight this and color code it to keep it organized. All the information with Samsung Edge in this problem, and by the way, this is a disclaimer that this is completely made up. I just completely made these numbers up. So actually, I want to do, let me get rid of this. I want to highlight the different brands with different colors. So let's say Verizon Information. They charge $50 for your phone, $75 a month. And Sprint does $125 for the phone, but $50 a month. And we're trying to figure out, after a couple months, one of these companies will be a better deal. We kind of want to see where that break-even point happens. In other words, where the lines cross each other. So first thing I notice is everything is kind of scaled by a multiple of 25. So on my graph, we're just going to scale this by 25s, 50, 75, 100. As long as you're consistent with the numbers, you don't have to put a mark on every one, but for graphing purposes, I'm going to scale off like up to 300. And if we need to add on to this, we can. Let's see, 25, this would be 50, 100, 150, 200, and 250, 300. How far did I go? I might have to expand this a little more. No, that's good for now. We'll stop there. Okay, so I guess the thing you want to ask yourself is, what are we keeping track of here? What are the X and Y axes representing? What influences what? So the measurable things I notice is how many months and total expenses are kind of the two things we're keeping track of. And one of those items is controlled by the other, and I would say the number of months that you have the service will dictate or will influence your total expenses. So I'm going to say that my X, or my independent value, is number of months. And I'm going to say that my Y, when I graph, will be my total cost. Total cost. Okay. So, let's see. For Sprint, wait, what was the first one? Excuse me. For Verizon, we have, I'm going to put my Verizon info here. Whoops. I'm having trouble with my colors. I apologize. For Verizon, my cost can be figured out. So I'm going to say Y is equal to the number of months that I have service times how much they're charging per month. So I'm going to say probably like, let's see, $75 times however many months I have it. Well, I don't know how many months I have service yet, but let's just say X represents the number of months. And then we can just also consider our total expenses will include the cost of the phone. So that would be $50. All right. And then Sprint kind of works the same way, just with a different rate. And so realize every time they give us a rate, we're looking at slope. So let's see, for Sprint, the rate or the slope in this is going to be 50 per month. So we'll say our total cost can be $50 times the number of months I use the company, and then I also have to add in the price of my phone, which was, what was that, 125. All right, so just a review from first semester and in this unit, here's our y-intercept, and here's our slope. Same thing here, this is our slope, and this is our y-intercept. All right, so I'll try to keep this color-coded. I'm going to stick with the yellow graph first. The yellow graph has a y-intercept of 50. So I'm going to go to my y-axis and mark it at 50. And then it rises 75 for every 1 unit. So I'm going to go up $75. Since I'm scaling by 25, that would be 25, 50, 75, and then over 1. So after the first month, oh, shoot, we didn't have to scale by 25s down there, did we? We're going to scale by ones. So this is the number of months. This is why you should put your headings down first. See, I'm still learning. Oh, darn it. Okay, well, that's okay. We'll just redo this scaling. 11, 12. Okay. So, and then our Y, gosh, I missed all this. I'm sorry. Our Y is the cost in dollars. That's a dollar sign. All right, there we go. Okay, so here, back to the graph. We have a y-intercept of 50. we have a slope of 75, and I like to repeat this process several times. As you learned the other day, the more points you can get on here, the more accurate this graph is going to be. So I think that's about as many as I can fit on this graph paper. All right, and then we'll do kind of the same name of the game on the other one. So looking at my equation for sprint, that one has a y-intercept of 125. So I'm going to go to 125. And a slope of 50. So it's going to increase $50. Notice I'm vertically changing by $50 for every 1 month that passes. And we can see that this point got marked twice on both lines. So this is an exact solution. And that order pair happens after 3 months. And the total cost is $275. All right, so once you get your graph set up, it's pretty easy. It's just writing the equations and figuring out what those relationships are to see where the lines intersect at. So that's that. I think we're going to do one more here on example 3. So turn to the back of your packet. And I want to graph this one so you can kind of see what happens sometimes when we graph. Backtracking the one we just did, if you look at the possible situations, if you had to guess, would you say this is a one solution, no solution, or a mini solution type of equation? All right, hopefully you said one solution, and this is, when you get one solution, we can clearly see that that's a one ordered pair that works. All right, now back to example 3. First thing I notice is that the first equation is in standard form, so some of you just like to rearrange it right away so the y is by itself, but honestly, I think it's just as easy to keep it in standard and then use our cover-up method. So I'm just going to create a little box here. That we can slide over. All right, so I'm going to get the x-intercept by letting y equal 0. In other words, cover-up method. So if I let y equal 0 and solve this equation, 4 times what is 8? That means x is 2. So my ordered pair would be 2, 0. All right, and then we can kind of do the same thing on your y-intercept. So I'm going to slide that over. If I cover up the x, that means I let, for my y-intercept, I let x equal 0. And to solve that, 2 times what is 8? Well, y is 4. So that's the ordered pair 0, 4. So y-axis, 1, 2, 3, 4. I'm going to put a point there. And 2, 0. And then notice my slope is down 4, run 2. So our slope is negative 4 over 2. Reduce that to negative 2 over 1. And what that does is it gives you the chance to put more points in. So I'm going to start back up at my y-intercept. I'm going to go down 2 over 1. And don't draw those lines in. I just did that so you could see that. But you can keep repeating that. Down 2 over 1. Down 2 over 1. Go the other direction. Down 2 over 1. And we should get enough points here to create our line. All right, so that was the first one. Try to keep this color coded for you. So that was the red equation. Let's do the other one and say green. All right, on the green one, if we use cover-up method, my x-intercept would equal negative 2, because we got to divide by negative 2. And the y-intercept maybe think of that as negative 1y. If we divide by negative 1, the y-intercept would be negative 4. So on my y-axis, I'm going down to negative 4. On my x, I'm going to negative 2. And my slope is definitely down 4 and over 2. Well, that should look familiar. That's exactly what we got before. When I reduce it, I can really see that the same thing is happening as it was before. I can go down 2 over 1. As long as I start at a point that I already know exists on the line, I can just keep repeating that process. And you can even work it in the opposite direction. But you should notice that if the slopes are the same, these lines are parallel, which means to answer the question, there is no solution. There is no point where the two lines intersect. And so every time you see parallel lines, we know there's going to be no solution here. Okay? We'll work on these a little bit more in class when we meet again, and we'll go from there. Adios.